All right, let's talk about our taxonomy wizard. So what happens here is that the first stage in creating an analyzable set of constructs in your project is that you want to define some seed constructs. What seed constructs are the variables, the constructs that you actually have to analyze in your project. Usually, this comes from theory. This comes from you. You are the expert in your field. You are the one that have defined this project. So you know better what are the constructs that you absolutely want to measure here. Usually these are the things that would go into your final model to do the analysis. Of course, your main independent variable or variables, dependent variable and variables, all the control variables are the things that you define here. One of the ways to do this is, again, to look at some anchor studies and see how they have defined their variables. For example, in this case, my anchor study has things such as multinationality, financial performance, and they clearly define what measurements were used in all of that. Like in my case, my anchor study has things such as financial performance, multinationality, R&D intensity, and firm size, firm age, and things such as that. And I will make sure that I will at the very least have these as my seed constructs. But in addition to that, maybe there are other things that I can measure in this study. Whatever the case may be, I can add seed constructs one by one. I can just say firm multinationality and then add a definition here. I can then create the seed. That's one way, manually add them one by one. The other way is we have defined a batch AI seeds option. What this one does is it will ask you to give it a seed paper, usually a one or two core defining papers in your field. You put it here, you give it some context of what your construct is, and then this can use that to generate a set of seed articles on nationality and performance. Like I added my core paper here. I would say, what is my target size? Let's just say, in this case, I don't want a lot. I will just do 10 of them. Control variables and moderators too. And then generate. This takes around 20 to 60 seconds. It will read the PDF. It will process that. It has some prompts to suggest the constructs that are good and can be analyzed in this project. And this is what it came up with. So if you remember, these were actually the ones that were measured in that paper, and we did a good job in suggesting what needs to be captured. It says, is this an outcome variable, a control, or independent? I can delete, edit, or add to this, and then or save these 14 to my seeds, or I can regenerate with more things. So that's our first step. We are starting with some seeds. I have already defined my seeds. I'm happy with their definition. So my next step is that, okay, I know the parents. I know the parent constructs. Now my job is to assign the measurements, like the different ways that all of these constructs have been measured, and put them under the relevant parent. So if you think about it, this is actually an assignment function. It is something about checking the similarity of your measurement definition with your constructs. We have different steps of doing that, and we have which include suggestions based on cosine similarity, like similarity between the definition of the measurement and the construct. similarity bit according to AI embeddings, like a little bit more involved machine learning method of doing that. Then for all the ones that were not assigned using this process, we have this clustering model. Here we explain exactly how this process works and how all of these functions work. You can spend some time working with that. But what I recommend running is this thing that will do all of these steps that I mentioned automatically. So after you have defined your seeds, you can go to our auto tab and assign all of this. You don't have to do anything else, and you just run the pipeline and it just automatically assigns everything for you. But let me just explain what is happening here. In the first step, which is our tier 1 assignment, what HubMeta does is it just checks pure word by word similarity. If in our construct we have defined firm size as the number of employees or how big the firm is, it is looking for those words in the definition of the measurement. So if it finds them, if the definition of the measurement is close enough in terms of cosine similarity, that will be included. And that's the first one. And here I will set it to usually a high number, like anything above 75% means very similar. So I try to be conservative here, like even set it at 0.8, because these will be automatically assigned. If you saw that level of similarity between that measurement and our construct, just go for it. Just pick that and assign them. Then the next one that you set is what happens is that the ones that are below 0.8 similarity, but still above 0.5 means it's some sort of a gray area. We don't know. So what we do for that is to include a large language model. So we will send the definition of the construct and the measurements to a large language model and say, do you think that this measurement belongs to this construct? Is this measuring the meaning of this construct? Is that a good way of measuring that? And it can say yes or no. And honestly, the way we have designed it is that LLM is not just saying yes or no. It's more than that. It says, I'm almost around 70% sure or 80% sure that these are the same. And that's where the accept score comes in. If I set it to 80%, that means the LLM's response has to be that these two, the measurement and the construct, have to be more than 80%, according to the LLM's decision, close to each other for it to receive an accept decision. So that's how it goes. And in the third round, if it's below this, it will just do some final round of measuring and just make sure if it is relevant to any of our remaining. So basically a final check if this is relevant or not. But the main decision is made in tier 1 and tier 2. So if you go ahead and run the pipeline, it's not going to cost you any AI credits. It just takes some time for it to run because it's a long process. Usually for something that is per about 1,000 article measurements, it takes about 10 minutes or so. So you can figure out how long it will take total. So you can see if we read this, it auto-assigned a few of them, and then it auto-assigned only 566 measurements because I set the auto-assign limit to very high. And then the rest of it, which was not auto-assigned, but was still above 0.5, it is being sent to an LLM. So the LLM is making a decision on 5,000 papers. So these are borderline items. We want to see where they belong, and we will pick a parent for them. So this will continue going on and on. Because we don't have time for that, I will just cancel this pipeline and then look at a generation that I've done in the past. So let's look at this one, for example. You can see your past runs here. So in this one, for example, what the LLM did was it assigned 567 of my 14,000 measurements. The rest of them, which were in the gray area, were sent to an LLM. 18,000 received an accept vote, 1,300 received a reject vote. Some of them were accepted after a second pass, and then you can see all the rest of all the other ones. So if I save these 2,500 measurements, my taxonomy becomes ready. So that means my measurements will be assigned to a parent construct. So I am done with my taxonomy. Of course, even after this saving, I still have a residual of 10,000 measurements. These 10,000 measurements are not relevant to the seed constructs that I had defined in my project. So I have not found a parent for them within those. But that doesn't mean they are useless. I can still find some clusters for them. And for that, we have this clusters tab. What this one does is that it only looks at the ones that do not have a parent. And here we have multiple different ways of generating a cluster. And you can read all about it in this note. When you run this, I just want to show you the final result so you have an understanding of what we mean by that. In a nutshell, what this process is doing is it looks at the semantic proximity of these remaining residual measurements and will suggest groupings for them. So basically we'll say, okay, this pack of 100 looks similar enough to each other. Perhaps they are measuring a construct like this. Let's see the results and I will explain more. So as you can see, it is running right now. It's a rather long process because it's basically running across my project 10,000 measurements and find those clusters or groups of similarity in meanings and putting them all together. We'll give it a second. We will give it a second and come back to it when it is finished. All right, now that it is finished, you will see that it has found different clusters, like 466 clusters to be exact, and each of them is its own group. And it also creates this visualization. In this case, because my data is very big, it might not be as easy and meaningful to look at this visualization. But if it is lower, you will see like the ones that are closer in meaning to each other are closer in this map and a similar color. But let's take a look at one of these clusters of meaning. So if I click on it, it will say, okay, all the measurements that have been detected to be close enough to each other. And when I look at this, I see a lot of things about foreign direct investment or trade, maybe trade barriers. They are not completely relevant to each other, but they are not that far-fetched either. So another one is Tobin's Q. It's a measurement for performance. You can see all of these are actually different ways of Tobin's Q. It's a performance measurement. So maybe there is something here. So 121 measurements in this cluster. So the next step we do is when we click on generate construct, it will feed all of these measurements in this definition to an AI and suggest a name and a definition for that cluster. So here it says, an obvious name, which is Tobin's Q or firm market valuation. Here is the definition. These measurements predominantly capture a firm's market valuation relative to its book value or asset replacement cost. This is a very good definition, I think. It can even be called firm performance, Tobin's Q. And then if I'm happy with this, I will define this as the parent construct and assign all of these 121 measurements under that. So if I click Save Node, I have one new construct, which is parent to all of this. And to double check, you can always come here and filter your constructs. it will show all the ones that you have already defined. Like this was the one that we just created, the firm performance Tobin's Q, and that's what we have. It's more refreshed to reflect the correct number. But that's it about our taxonomy. It's a different platform of its own, so this one, it was a longer video compared to the rest of them. See you in the next one to talk about exporting and analyzing our data.